Welcome back, geometry class, as we continue our unit on rigid motion. Today's lesson about reflections, the old flippity dip. Okay, so the reflections, that's what we're learning about today. So we're going to talk about reflecting a point across a line, graphing a reflection image, and writing a reflection rule. Wait till you see that. That's a mess. So you might wonder, well, what in the world is a reflection? Let me show you this little thing. It's a resource on the online textbook. I'm not going to go over it, but I want to let you know it's there. In the online textbook, there's a section called Solve It, and there's this neat thing where it gives you this picture, and you're supposed to like flip these shapes over a line, you reflect them, and you see what word is there, and it's kind of cool. So totally go online and play around with that. That's fun. All right. But now let's do some notes. Yeah, notes. Let's learn about reflection. So what is a reflection? It's a flippity dip, right? Boom, boom, flip. And it goes across a line of reflection. So you'll see a line of reflection. Now, this is one of my favorite notes ever. Reflection notation, right? How do we write a reflection rule? This is it. This is reflection notation. Look at that mess. Let that sink in, but learn how to read it. The reflection of the pre-image P, right? Pre-image P, across line M, is image P prime. Is image P prime. Okay? So, the reflection of, notice the capital R, the reflection of pre-image P across line M is P prime. That's how we read it. And we're going to do more of that in the lesson. Okay, so make sure you have that note. Click pause. Make sure you do that. Pause the video. Read that. All right. Now here's a neat thing. If points in the reflection are not on the line of reflection, the line of reflection is the perpendicular bisector. Remember that word from constructions. The perpendicular bisector of the segment between the points of the pre-image and the image. Yes, memorize all of that. No, just kidding. Don't memorize that. Just make sure you understand what's happening in this picture. Okay, so in the picture, notice here's a line of reflection M, right? In this picture, triangle ABC is getting flipped over that line. If there is a point in the pre-image that's not on the line of reflection, once you reflect it, the distance from B to B prime in this case, that perpendicular bisector is the segment between B and B prime. And it perpendicularly, I guess that's a word, I just made it up, perpendicularly, too many L's, it bisects it, okay? So the same thing with C and C prime, that the segment between C and C prime is the perpendicular bisector of the line of reflection. So really you just need to understand that concept. It bisects the line of reflection if it's not on the line of reflection. Anyhow, some cool stuff. You don't need to memorize that, but understand the concept. Reflections are indeed rigid motions. Remember, rigid motions do not change size and shape. So that is a reflection, right? If you don't know any of this at all, make sure you click the pause right now, write all that stuff down, make sure you understand it, and let's get to work. Shall we? Yes, Mr. Katz. Okay. The next thing. So the next thing is this. We're going to start jumping into reflecting a point across a line. That's what we're going to do. We're going to reflect a point across a line. And I'm going to start with this little question here. Point P, right? Point P has coordinates 3, 4. What are the coordinates of blah, right? So remember that notation we talked about in the notes. How in the world do you even read this, right? How do we read that? We read that as the reflection of point P across y equals 1. Okay, so the reflection of point P across y equals 1. Point's the thing being reflected. This is the line that's happening. Okay, so now how in the world are we going to do this? We have coordinates at point P, 3, 4. We're going to reflect it across a line of y equals 1. And you might be wondering, Katz, dude, time out. What in the world is the line y equals 1? How is y equals 1 a line? And this is how. Remember your vertical and horizontal lines when graphing. We have to remember some algebra. Okay, so remember vertical and horizontal lines when graphing. So it's a trip down algebra memory lane. First thing you got to remember about algebra memory lane. If you have an equation that looks like this, y equals some number. There's no x, right? There's no x in the equation. Y equals some number. That's a horizontal line, right? It's a horizontal line. C is whatever number a kid. Y equals 3, y equals 10, y equals negative 4, y equals negative 1/2. Whatever it is, it's a horizontal line. There's no x. You got to remember that from algebra. The next thing to remember, vertical lines. The equation of vertical lines. X equals blank, right? So there's no y in the equation. X is some number. X equals 11. X equals negative 14, right? Whatever. That is a vertical line, up and down, right? As long as it's any real number. So you can remember that. Remember your vertical and horizontal lines. And then you might be wondering, well, Mr. Katz, what if it's like a slanty line, right? What if it's a slanty line? Well, remember this? Y equals mx plus b. No! Yeah, so y equals mx plus b. It's a line, right, that has a slope of m, rise over run, right, up to the up or down and right and left, rise over run, and a y-intercept at b. That's your slantiness. Okay, so the slope is your slantiness. So the fact that we have both a y and an x in the equation brings in the slantiness, and the coefficient for x is your slope. It determines the rate of change, but that's algebra. So make sure you remember that stuff, right? And that's going to be helpful coming into this problem. So how in the world, cats, how in the world are we going to answer this question? Point B has coordinates at 3, 4. What are the coordinates after the reflection? So what we can do is give ourselves a picture. Okay, so let's give ourselves a picture, and then we can make seriously a rough sketch of a graph. You know, give yourself like 4 or 5 tick marks in each direction. Give yourself a graph to look at, you know, and then see what's happening. So here's the graph that's there, and we have coordinates at 3, 4. If you remember, it's your x and your y. So 3 in the x, 4 in the y. 1, 2, 3 in the x, 1, 2, 3, 4 in the y. Here is point P, right? Your coordinates at 3, 4. Now, what is happening with the reflection rule? It's reflecting across y equals 1. What in the world would that y equals 1 line look like? Y equals 1 is a horizontal line. It's a horizontal line going through the y coordinate of 1. It's a horizontal line going through the y coordinate of 1. See that y coordinate of 1? Now, what's a horizontal line look like? It looks like this. Bloop, 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 bloop. Looks like the horizon. You're welcome. Okay, so it looks like the horizon. That's a horizontal line. So we have our line of reflection. So remember what a reflection is. It's a flippity dip. Flippity dip. So we're going to flip the P, reflecting that point across the line of reflection. So how do we do that? Simple. Count. Dudes, count. So we're going to count again. How far is point P from the line of reflection, right? So how far is it? It's going to come straight down the line. How many coordinates away? It's count 1, 2, 3 coordinates away from the line of reflection. Okay, so what we're going to do is reflect it. Give it 3 more coordinates away. Symmetry, right? Reflection. 1, 2, 3 more spaces, and there is our P prime, right? The new point. Okay, so we have reflected that P, the flippity dip, across the line of reflection. Whoop, just like that. So all we need now, what are the coordinates of that new line? What are the coordinates of the reflection? So where is this new point? Now notice what happens. Where is this point? It's at 3, negative 2, right? That's interesting. It's at 3, negative 2. That's where the new coordinates are. Hopefully you find something interesting. So look at the original coordinates, what we flipped it over, what we reflected it across, and look at the new coordinates. Notice that the x stayed the same, but what's going on with the y? How many units is 4 from 1? 3. 3 units down. 3 more units down from 1? Negative 2. So you can actually visualize this in your mind if you want, but that is the solution. So what are the coordinates of the reflection? 3, negative 2. And that's how a reflection works across a given line. The most important thing, though, is to remember this note. So if you don't know this note, pause, learn, ingest, relearn algebra, what have you, but that's there for you, okay? Okay. Next question. We ain't done. What is the image of P, coordinates 3, 4, reflected across the line x equals negative 1? So here we go again. So what what's going on with this question? Right? We're reflecting a point across a line x equals -1. So what would be helpful? Let's see. Let's actually see the line x equals -1. So give yourself a picture, folks. And you don't need graph paper, I don't think. Well, maybe you do. If you do, get some. If you've been drawing coordinate planes as long as I have, maybe you don't need graph paper. Anyhow, give yourself a coordinate plane. Give yourself the coordinate 3, 4, right? It's in the same place as the previous problem. 1, 2, 3, 4. It's up here. There's point P. Now what we have to do is figure out where in the world is the line x equals -1. Remember your note, right? X equals something. That's a vertical line. Oh, up and down. Vertical line. Okay, so your x equals is your vertical line. So x equals -1 is a vertical line where x is -1. There's a vertical line where x is -1. So let's draw a vertical line where x is -1. And we're going to be reflecting across that line. So we're going to take that point P and flip over x equals -1. Just like that. So let's do that. What would it look like? Well, how far is P from the line of reflection? Okay, so let's figure it out. We got 1, 2, 3 until the y-axis. Duh, right? Isn't that neat? 3 until the y-axis. And then 1 more. Okay, so we went 4 units to get to the line of reflection, right? 4 units to get to the line of reflection. So let's do 4 more units away from the line of reflection. Right, so 1, 2, 3, 4. What would be 4 more units from -1? It would be -5. So here's our P prime. And where is it at? The x, instead of 3, is now all the way at -5. It's still the same height. It's still at the y of 4. Okay, so the new ordered pair is now at -5 on the x because of the way we counted. And the y-coordinate is the same. We just reflected it over x equals 1. The y-coordinate doesn't change. Trust me, stuff gets nuts when we start reflecting it over slanty lines, but we're not doing that now. Anyhow, so there's the image, right? The image of P is P prime, so I should probably label that as P prime. P prime is at -5, 4. And that's the concept of reflection. How cool. If this was confusing at all, pause, rewind, look again. Next problem. This is a fun one. I give you a graph now. Yay. We're going to start graphing a reflection image. So now we're going to start graphing. So we have coordinate geometry. We're going to graph points A, B, and C, and then we're going to label whatever this is, right? So we're going to graph A, B, and C, and then label whatever in the world that is. So let's begin by graphing what it's saying, because it's telling us graph points A, B, and C. Let's do that. So point A is at -3, 4. Remember how that works. -3 in the x, +4 in the y. There is point A. Now we're going to graph point B. 0 on the x, 1 on the y. Here is point B. And then C is at point B down here. C is at 4 on the x, 1, 2, 3, 4, 2 on the y, and there is point C. Now you can see a nice little triangle about to present itself. Okay? So if you want to, you can draw your triangle. You can use a straight edge too if you want to. I don't think it's that important right now, so I don't care. So I'm just drawing the triangle there. So now all we've done is read the problem. We've graphed it. Now it's saying graph and label. Bleh. What in the world is that? Remember how that is read. The reflection of triangle ABC across the y-axis. Okay? The reflection of triangle ABC across the y-axis. So we're going to be flipping this triangle across the y-axis. Okay? So that's about to happen. Now how do we do it? It's very similar to what we just did in the previous example. Let's take a look at point A. How far is point A from where we're reflecting across the y-axis? So A is 1, 2, 3 units from the point of reflection, or the line of reflection. So let's go 3 more units. 1, 2, 3. Now we have our new A, otherwise known as A prime. Okay, so we have that. And now we're going to do the same thing with point C. How far is point C from the line of reflection? We got 1, 2, 3, 4 units. Okay, and then 4 more units. 1, 2, 3, 4 more units. And here is our new point C, what we'll call C prime. right? And then where is the B? The B is on the line of reflection. So guess what? B is also B prime. There it is. Okay? So there it is. And now what we're going to have to do is graph and label that new triangle. So we have it. Remember our new point A prime? Now this one I'll use a straight edge for because I'm ready to answer the question. So we have our A prime and our C prime, right? Look at that. It's a beautiful triangle. The B is the same as B prime. It stayed right there. And then from B to C. Look at that. Bam. Isn't that beauty? That's a beaut, ladies and gentlemen. So look at all that nutty stuff that just occurred. But really, the main thing is, Mr. Katz, how do you do this? And the main answer is count. If you can count, you can do it. Let us do another graphing a reflection image problem. So let's do another example, right? So I got this. Same type of setup. We're going to graph points A, B, and C, and then graph and label if it's reflected across the x-axis now. All right, so we're going to do the same thing. Now I'm going to move a little bit quicker. So let's go. Point A at -3, +4. Point B at 0, 1, same place. And point C at 4, 2. 1, 2, 3, 4, 1, 2. Okay, so I have my triangle. I don't care to draw that one really well because it's not really the question. Now we're going to graph and label this noise. How do we read this? The reflection of triangle ABC across the x-axis now, right? That subscript is the x-axis. So we're going to be reflecting it. So it's going to be reflected across the x-axis now. Oh, I thought I messed up, but I didn't. So that's what's happening. We're going to reflect it across the x-axis. So the same thing. Can you count? Well, then let's do it. All right, A. 1, 2, 3, 4, and then 1, 2, 3, 4 more. A prime. B. 1 away, 1 more away. B prime. C. 2 away, 2 more away. C prime. See how fast you can do this, right? All we got to do now, connect the dots for a beautiful triangle. Now this one I'm going to use a straight edge to make it look pretty. Oh, that's so pretty, Mr. Katz. Yeah, isn't that awesome? Precision tools, ladies and gentlemen. And there we go, right? We have now graphed and labeled A prime, B prime, C prime. That's our new triangle. Right? Reflections. Yay! Okay, a couple more concepts now. We're going to write a reflection rule. We're going to see if we can remember this garbage, okay? So let's write a reflection rule. Take a look at this example. So I give you a picture with like stuff going on, right? There's stuff going on here, triangles everywhere. It's like a triangle monster just threw up, right? So each triangle in the diagram is a reflection of another triangle across one of the given lines. Each triangle is a reflection of another across one of the given lines. How can you describe triangle 2? So what we're going to do, describe triangle 2 using a reflection rule. Well, where in the world is triangle 2? Right there, okay? So how can we describe that triangle? Where could triangle 2 have come from a reflection? Okay, so triangle 2 was reflected. Was it reflected over M? No. Was it reflected over K? Yes, right? Totally, if we took this triangle and reflected it, we'd get 2. So we know we have reflected triangle 4. Here's the trick, folks. We know we're dealing with a reflection rule. So we know we're dealing with a capital R. We know that it has been reflected over K, so we know it's going to be reflected over line K, or you can write just K. The only thing is what was reflected. 2 is the result of reflecting 4. So we actually reflected triangle 4. Okay, so that's the rule. The reflection of triangle 4 across line K. That's how that is read. Okay, the reflection of triangle 4 across line K. That's how that is read. And you have to. For those of you that aren't in my class, I make my class repeat stuff a lot of times, and they hate it. But dudes, deal with it. That's how you learn stuff. So this is the reflection rule, okay? So that's how that works. Not good enough? Fine. Do another example. Okay, same picture. Okay, same picture. Each triangle diagram, reflection of another triangle across the line. How can you use a reflection rule to describe triangle 1 now? Okay, so now we're going to describe triangle 1. Well, where's triangle 1? Triangle 1 is right there. Where did it come from? It came from triangle 3 being flipped over line M. So if it was a reflection, right, a reflection over line M, right, that's how we begin that, reflection over line of triangle 3. Piece of cake. That's how that works. But you have to know how to read this stuff. And the only way to learn how to read it is to keep reading. When you write these things down, you can't think RM triangle 3. No, the reflection of triangle 3 across line M, or the reflection across line M of triangle 3. It's all reading. That's how you do it. Cool? Great. Quiz. Okay. Let's do a quick quiz. So read this first thing. Point D has coordinates 4, 1. What are the coordinates of the reflection of point D across x equals 2? So let's do a quick diagram. Now the coordinates are 4, 1, so we don't need too many tick marks. Let's go, I'll do 5. We don't even need any in the y, right? So here we go, coordinates 4, 1. 1, 2, 3, 4, 1. And now we're going to be reflecting it across line x equals 2. Remember what x equals 2 is? It's a vertical line where x is 2. Okay, so you got to remember that algebra bit. So if we're going to reflect that point across the line, how's that going to work? We count. 1, 2 to the line, 1, 2 more, and where do we end up? Right on the y-axis. We're at 0, 1. That is the new set of coordinates, right? Isn't that cool? That's a neat little quiz. All right, so the next one. So we have this picture here. What are the coordinates of triangle ABC when reflected across the y-axis? Here's the y-axis, and what we're going to do is reflect. We're totally going to reflect. So let's count. Can you count? Here's A. 1, 2 to the line, 2 more, A prime. So where is A prime? A prime is at -2, +4. All right, that's how that works. So if you totally didn't get what just happened, hit pause, rewind. A is 2 units from the line of reflection. 2 more units gives us A prime. Where in the world is that? Because the question is asking for the coordinates. It's at -2, +4. Bam, A prime. All right, continue playing. B. Now, what's going to happen to B? Let's count. Can you count? 1, 2, 3, 4, 5, 6 to the line. So 6 more. 1, 2, 3, 4, 5, 6. Here's B prime, way out there. So what is the coordinates for B prime? Where is B prime? It's at -6, +2. -6 in the x, +2 in the y. And then lastly, same thing for C prime. C is 1, 2 from the line, 2 more, C prime. Where in the world is C prime? It's at -2 in the x, -6 in the y. And there are your coordinates for the reflection. Okay? Okay. Here we go. Next question. Last one. Triangle ABC has vertices A, B, and C. The reflection of the image has these vertices. What is a rule that describes the reflection? Whoa. That is a crazy question. I love it. You know what you can do? Draw a picture. Give yourself a picture. I love this question. Okay, so our coordinates are going out to 5s pretty much. Let's do that. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Let's draw our triangle. A is at -2, 0. I'm moving kind of quickly, so if I go too fast, pause, rewind. All right, A is at -2, 0. B is at +2, 5. So here's B. And then C is at +3, 1. Here's C. Okay, so we have this triangle. Now, you know what we also have? We have a reflection image with these coordinates. A prime is at -2, 0. So guess what? A prime is in the same place. B prime is at 2, -5. Okay, so B prime is at 2, -5. Down here, there's B prime. And then the last one is C is at 3, -1. Here's 3, -1, and that is C prime. So this is our new triangle. Huh. What do you think just happened, right? What just happened? This thing reflected over the x-axis, right? So this totally thing reflected over the x-axis. So guess what the rule is? We can totally write the rule. What is a rule? Reflection over the x-axis. Okay, we got to remember that format. Again, read these things correctly. Reflection over the x-axis of triangle ABC. There's your rule. All right, so that's your rule. Reflection over the x-axis of triangle ABC. Ta-da! Isn't that neat? That's some neat stuff. So that is the lesson on reflections in a nutshell. I hope you enjoyed the nutshell. We'll be back another time.